the Chapter 10 review, Mrs. Falk's favorite lesson, circles. So what is the measure of x and y in degrees? The entire figure, entire circle, would be 360 degrees. 104 and 64 is a total of 168. I'm going to get my calculator here. 360 minus 168 is 192. That's all you're doing on this question here. You're not being asked, you don't need to find x and y. You can't even find x and y because these are not quite vertical angles. So the answer, 192. For number 2, give the center and radius of circle A and B and describe the intersection of the two circles. I don't know why that just dropped down there. So A and B. The center of A is 1, 2, 3, 4, 5. 1, 2, 3 is 5, -3. And the radius of A is 2. For B, the center is 1, 1, 2, 3, -3. Now, these circles intersect at this point here. 1, 2, 3, 4, 5, 6, 7. That's the point of intersection, or also the point. They also share they're called tangent circles because they share just one point. That means if they're tangent circles, they only have one common tangent, and it is going to be along this line here. So I would graph that line like that, and the equation of that line would be x equals 7. So when they just say describe all common tangents, that's what they want you to be able to say, that the tangent is the line of x equals 7. AB is tangent to circle O at point A, not drawn to scale. Find the length of the radius r to the nearest tenth. So that means that where the radius intersects the tangent segment makes a 90-degree angle. Okay? This is the radius here. This length here is also the radius. That means my hypotenuse, my total length here, is r plus 8. I'm going to be using Pythagorean theorem, so I'm going to be squaring everything. One leg is the radius squared. The other leg is 11 squared equals r plus 8, quantity squared. So r squared plus 121 equals, I have to FOIL this. So if you need to do this to FOIL, I should get here that I'm going to get a perfect square trinomial because this is r plus 8 times itself. R squared, 8 times r is 8, 8 times r is 8, that's going to be 16r plus 64. In this problem, both of the r squareds are going to cancel out from either side. I get 121 equals 16r plus 64. I'm going to subtract 64 from both sides. 121 minus 64 is 57 equals 16r. And 57 divided by 16 is 3.5625. It says round to the nearest tenth. The answer is 3.6. For the next problem, given circle O with a radius of 5. So O to B is going to be 5. And O to C is 3. Find the length of AB. Well, I'm going to use Pythagorean theorem to find CB. You may recognize that this is a Pythagorean triple, so it's going to be 4, 3, 4, 5. But if you didn't, 3 squared plus this other leg, I'm going to use question mark. The reason I'm not going to use the letter B or C is because they're using those variables to recognize points in this problem. Equals, I've already started to put 25, but I'm going to step by step, 5 squared. 3 squared is 9, plus question mark squared equals 25. I subtract 9 from both sides. I get that question mark squared is 16, so question mark is 4. They want the entire length of AB. Since this is intersecting at a 90-degree angle, I know it's a bisector, I know it's a perpendicular bisector, it's going to bisect both of these sides. The other thing that I know is that that would also be a radius. So I could also say that these two triangles are going to be congruent triangles by hypotenuse leg. It's a 90-degree angle. I have both hypotenuses are 5. They share a common leg, which is 3, so this has to be 4. 4 plus 4 is 8. So the length of AB is 8. Number 5. So this one I get a little nervous when I'm doing it. If this circle, this is a circle, it's 360 degrees. I'm going to subtract the first known arc, which is 270. And I'm going to subtract the second known arc, which is 45. That leaves me with 45, so that's good. That means that this arc here is 45. So since both of the arcs on the same circle are congruent, the chords intersecting those arcs have to be congruent, so x has to be 6. If these weren't congruent, you really do not have enough information to do this problem. So on this one, the measure of angle x is 110 degrees. WZ and YZ are congruent, that's marked. Angle Y is 100. Now, when I first did this problem in study hall, that only 2 people attended, I had to play around with it. It took me a while to get it. So if it takes you a while to get this one, it's okay. First thing I did is I saw, that's good, they're going to want to know the angle, measure of angle Z, and the measure of angle W. Since this is a quadrilateral inscribed in a circle, the opposite angles are supplementary. So 110 and 70 make 180. And angle W have to be 80 because it's supplementary to 100. So I can fill this in. So this is 70 and this is 80. Now, WZ, this arc, is going to have to be congruent to this arc. And this whole larger arc here is created by inscribed angle x. So we learned that if the vertex of an angle is inscribed on a circle, the arc across of it is twice the angle. So that means W to Z to Y is 220 degrees. Since WZY, that's arc WZY, is 220 degrees, and it's made up of 2 congruent parts. Each part is 110. So W to Z is 110. Now I'm going to look at arc WX. Okay, so WX is made up of angle Z, but I don't have that measure here. Okay, it's also part of angle Y. And since I know part of the arc opposite angle y, I can find that. So this WZ is part of that large arc. Okay? So arc ZWX. Oops, I don't know why I just said it. ZWX is 200 degrees. I want just W to X. I know that this part is 110. So just W to X would have to be 90. Next problem, number 7. Given that angle DAB and DCB are right angles. So since these are right angles and they are inscribed in a circle, I know that the hypotenuse is the diameter. Okay? So I know that this is the diameter. DBC is 42. That means that this is also 42. So what is the measure of CAB? So I want the measure of arc CAB. Okay, so this is 180. This is 42. It creates it's an inscribed angle. It creates this arc. So that's going to be twice that. So that's going to be 84. So 180 plus 84 is 264. Next problem, diagrams not drawn to scale. BCD is 111. DEF, I'm going to use a different color just so you can see this a little better. I thought I was going to use a different color. DEF is 100. FGH, so I'm going to go back to blue, is 127, and HAB is 22. Find FPD. So I'm finding the external angle created by two secants that have a common endpoint outside the circle. For that, I take the measure of both arcs. 100 minus 22 is 78. And I divide that by 2. And I get 39 degrees. So once again, on the calculator, 100 minus 22 is 78 divided by 2. Diagram not drawn to scale in the given information. Angle AB is 59 degrees and CD is 47. We want to find that angle. So since these are two chords that intersect inside the circle, I add them together and I divide by 2 to get that angle. So 59 plus 47 is 106, divided by 2 is 53. So the answer for number 9 is 53. Number 10. Suppose you stand at a distance from a circular building. Assuming your line of sight forms tangents to the building and make an angle of 22 degrees, what is the measure of the arc of the building that your lines of sight intersect? So, do this really neatly for you guys. There's the circular building. you're standing here. So when you look at the building, you don't see the whole building. You obviously see part of it. You can't see around the back. Okay? Is that you actually separate this entire circle into two arcs. One of them is here, one of them is here. This is the arc you want to find. So if you had an entire circle and you took, that's 360 degrees, and you took away the part that you see, the part that you don't see of the circle is 360 minus x. So 360 minus x, right? Minus another x. So basically, you're taking the larger arc and subtracting the smaller arc, dividing by 2, and you're going to get the measure of the angle, which is 22. So 360 minus x is 360 minus 2x divided by 2 equals 22. Now I could do this problem two different ways. So I'm changing the color and writing over here. I could first, since 360 and negative 2x are both divisible by 2, I would probably do 180 minus x equals 22. And then 22 minus 180 is negative x equals 158. So x equals 158. The other way I could have done it is I could have multiplied both sides by 2, and I could have gotten 360 minus 2x equals 44. 44 minus 360 is negative 316. I brought down that negative 2. And negative 316 divided by negative 2 is 158. So either way I solved this, I get the same answer. The key to remember here is that since it's tangents, it's breaking the circle into two arcs that are going to add up to 360 degrees. The part you see, we're calling x. The part you don't see would be the leftover. So 360 minus x is the part you don't see. Okay. Find the value of x. So now here, we're finding lengths. These, therefore, is the theorems that we learned in lesson 10.6. That's the first place kids get confused. Here, these past problems, we've been dealing with measures of arcs and angles. 22 and 100 are not the lengths of the arcs, they're the lengths of the, 122 are not the measures of the arcs in length, they're the measure in degrees. Now we're getting into the measure of segments in actual lengths. In terms of arcs in actual lengths, we will deal with that next week in chapter 11. So this said you multiply each of the portions of the segments together. So 24x equals 6 times 32. 6 times 32 is 192. So 24x equals 192. 192 divided by 24 is 8. So x equals 8. That's an actual number in length. Again, two chords that intersect inside the circle. So x times 24 is 24x. 12 times 8 is 96. 96 divided by 24 is 4. So number 12, x equals 4. Number 13, this is the last lesson that we learned. So we have to remember that the equation of a circle in standard form is x minus h, quantity squared, plus y minus k, quantity squared, equals the radius squared. So my center of my circle is 4, negative 3. 1, 2, 3, 4, 1, 2, 3. Now I want a radius of 5. So the easiest way to do this is to count 5 spaces to the right, to the left, up and down from the center of the circle, and then just connect them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now it's really kind of ugly, but I get the point that you're drawing a circle. Okay. Write the standard form of equation of a circle with this center and this radius. So once again, you have to remember x minus h, quantity squared, plus y minus k, quantity squared, equals radius squared. X minus negative 3 is x plus 3. Plus y minus negative 4 is y plus 4, quantity squared, equals radius squared, equals 36. A segment with endpoints on a circle is a chord. So number 16, you are standing at point B. Point B is 16 feet from the center of a circular water storage tank and 15 feet from point AB. AB is tangent. They want you to find the radius of the tank. Okay? So R squared plus 15 squared equals this whole is 16. So 15 squared equals, let me put the R squared here. 15 squared equals 225. 16 squared equals 256. 256 minus 225 is radius squared is 31. The real answer is the radius is the square root of 31. Approximated to a decimal, though, is 5.6. So I need to put in the directions here, find the radius of the tank to the nearest tenth. Number 17, given circle O, B, A, C, okay, is 290 degrees. They want me to find the measure of angle B. So I don't know, I haven't done this problem yet to walk you through it. The first thing I'm going to say, if this is 290, then this here is 70, which means angle A is 35 degrees, okay? I can see that AOC is a diameter, okay? That means A to B to C is 180. So A to B to C would be 180. If B to C is 70, A to B is 110. And A to B is also intercepted by central angle O. So that would have to be congruent as 110 degrees. So angle B is part of this triangle. So if I started with 180, I subtract angle O, which is 110, and I subtract angle A, which is 35. I get that angle B is 35 degrees. The other thing that you might have realized, that I didn't realize at first when I was doing it, and I'm just realizing it now, is that once you got that A was 35, you actually didn't have to do this, because you can see that A to O is a radius, and B to O is a radius, which means the angles opposite them are going to be congruent. This makes an isosceles triangle. So I actually didn't have to do the 110 once I found that A was 35. I know that B is 35 also. How many degrees does a minute hand move in 35 minutes? So it goes from here to here. So it's that whole part. So basically, I could do 180, but there's 360 degrees in a circle. Okay, so 35 minutes divided into 12. So it's moving 30 degrees every time it moves. So 30 times 7 is 210. Find the value of x. This is a right angle. So I can make a line there. That's going to be a radius. That's also going to be a hypotenuse of this triangle. So if this entire length is 12, since it's intersecting it at a right angle, it's bisecting it. So that's 6 and 6. I'm going to use Pythagorean theorem. 3 squared is 9, plus 6 squared is 36. Equals radius squared. In this case, radius is also x. It's a radius. So 9 plus 36 is 45 equals the radius squared. If I want the square root of 45, it's 6.7 if I ask for this rounded to the nearest tenth. And I think that's the way in the answer key, but I think I'm going to say in simplest radical form on the test, because I want you to practice that. That would be 9 times 5, square root of 9 is 3, so in simplest radical form, that's 3 radical 5. Now remember, as a decimal, this was 6.7. If you actually did 5 square root times 3, you would get 6.7. For problem 20, they want you to find the measure of angle PSQ, and they give you an expression for PSQ, and they also give you an expression for PRQ. And you can see that both PSQ and PRQ are inscribed angles that intercept the same arc, which means they're going to be congruent. So if PSQ is 3y minus 15, and PRQ is 2y plus 25, you can set them equal to each other. I subtract 2y from 3y, I get y. I add 15 to both sides, I get 40. If y equals 40, I plug that back in. 3 times 40 is 120, minus 15 is 105. So definitely doesn't look drawn to scale, but that is 105 degrees. For number 21, I'm given that IED, so this angle here is 116, and that JFG is 100. They want me to find the measure of each interior angle. Since it's quadrilateral inscribed in a circle, opposite angles are going to be supplementary. Angle 1, though, and the 100-degree angle make a linear pair, so they're also going to be supplementary. So angle 1 is 80. That means that angle 3, which is opposite it, is 100, because 100 plus 80 make 180. Now, 180 minus 116 is 64. So angle 2 is 64. 64 and 116 are supplementary. That means angle 4, which is opposite the 64-degree angle, is also 116 degrees. I say also because it was also supplementary. For number 22, a hummingbird is flying towards a large tree that has a radius of 6 feet. When it is 31 feet from the center of the tree, the lines of sight form 2 tangents. What is the measure of the arc of the tree? So I want that and that. And this is 90 degrees, and this is 90 degrees because where a tangent and a radius intersect at a point of tangency, which makes a right angle. So these 2 triangles are actually congruent by hypotenuse leg. They're both right triangles with a hypotenuse of 31 feet and a congruent leg, which is both the radius here, is 6 feet. I can also use this and find the measure of this angle here. And actually, I'm going to erase that, and I'm going to call that angle theta because I'm using a trig ratio. This is a right triangle. I have the adjacent side, 6, and I have the hypotenuse of 31. And adjacent and hypotenuse gives me cosine. So 6 divided by 31 equals that number. I'm going to do that in my off-screen calculator and have the same thing in my off-screen calculator, because in my off-screen calculator I want to find the cosine of this. Since I'm finding the measure of an angle, I'm actually using the inverse cosine, so I'm going to press secant cosine -1, and I get that this angle theta is 78.84 degrees. Since this angle theta is a central angle, this arc is also 78.84. But since I have 2 of these, I need to multiply it by 2 to get what the bird sees is 157.68 degree arc. And I need to change this on the test to the nearest tenth. Make sure that's specified. Write the standard equation of a circle with its center at the origin and radius 3. So I need to remember that my standard form of my circle is x minus h, quantity squared, plus y minus k, quantity squared, equals radius squared. Since my origin is 0, 0, x minus 0, which is the x coordinate of the center, would just make x squared, plus y squared, because k is also 0, and y minus 0 is 0. Y minus 0 is y. And the radius squared is 3. The radius is 3, so 3 squared is 9. So it's x squared plus y squared equals 9. For number 24, use the diagram. It's not drawn to scale. B to C is 18. and C to D is 22. These are lengths of segments. I have a tangent and a secant. So for the format from that is the tangent segment squared equals the external part of the secant times the length of the entire secant. And this secant, the external part, plus the diameter, which I'm trying to find, is the total length. 22 squared is 484. 18 times 18 is 18 squared, 324 plus 18d. So 484 minus 324 is 160 equals 18d. 160 divided by 18 is 8.8 repeating, so round to the nearest tenth is 8.9. So a park maintenance worker is standing 15 meters from a circular monument. If you draw tangents from the maintenance person to each side of the monument, they make an angle of 37 degrees. What is the measure of the arc? So, we had a problem like this before. This guy is standing 37 degrees. The fact that he's 15 feet from the circular monument doesn't really make a difference. If he's 37 feet and he's tangents, okay, then we had one like this before. This interior angle is x. That's what we want to find. Whatever x is, this exterior is 360 minus x. I think I said interior earlier. So I didn't mean that. 360 is the total circle. We're actually finding the smaller arc and the larger arc. These tangents are breaking this into two arcs. So we take the larger arc, subtract the smaller arc, divide by 2, and we need to get 37. So I'm going to rewrite this up here. 360 minus x is minus 2x divided by 2 equals 37. I showed a problem just like this earlier in the lesson, and I said you can do 360 minus 2x and divide both of those by 2, or you could multiply the 37 by 2. I think it is much simpler. Just do 360 minus 2x. Both of those divided by 2 is 180 minus x equals 37. So if I have 37 and I subtract 180, I get, I don't want that in there. I get negative x equals negative 143. So that means that x is positive 143. Once again, the 15 is just a distractor. And if it makes you feel better, when I first did this video, I started trying to do 15 and the radius was x and used trigonometry, and then I realized, oh, it's just a distractor. I don't need that. Number 26. A small messenger company can deliver only in a small part of the city. Write an equation for the boundary where the company delivers and find its radius. Well, I can see that the center of the circle is at 1, 2, 3, 4, 5, 2. So I remember that my formula for a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals the radius squared. X minus 5 for the x value of the center of the circle, y minus 2 for the y value of the center of the circle, and the radius is 1, 2, 3, 4, 5. 5 squared is 25. Okay? That's all the problem needs. Number 27, this one is very tricky. So, a footbridge is in the shape of an arc of a circle. The bridge is about 7 feet tall and 23 feet long horizontally. What is the radius of the circle that contains the bridge? And one of the first things I always say is if you do not understand the question, I did not understand this question, draw a picture. So that's not a diameter of a circle, that's just part of the circle. And from one edge to the other is 23. And this height is 7. And I will admit, it took me a lot of time to figure out what I was doing here. And the best way I could figure it out was to think about what I kind of had and what I had learned. So I definitely have segment lengths here, and I learned about chords inside of a circle, secants in a circle with an external point of intersection, and tangents. And I can see then when I start going through these, well, these definitely do not represent secants or tangents. So I thought about, well, what if they represented chords? So I would have a circle here. And this would continue on down. And it made sense that if this was the center of the bridge, was 7 feet tall, then each of these was 11.5. And I started to realize that I had 2 chords here cut at the point. One of the chords was 11.5 times 11.5. I could multiply the 2 parts of the chord together, and whatever that product was, which in this case, 11.5 squared, is 132.25, had to equal 7 times the other part of the chord, which I didn't know what it was yet. Okay? So, but if I took this 132.25 and divided by 7, and that's going to be roughly 18.89. That represented that bottom part of the chord in length. When I added the top part of the chord, I got now that the whole thing, the diameter, was 25.89. They wanted the radius, though. And I got that the radius was 12.94 to the nearest tenth, 12.9. So once again, the only way I was able to do this problem was to start to draw a diagram and think about what I had actually learned in this section that I could apply. And the only thing that I've learned about lines intersecting inside a circle was chords. Okay, number 28 is a little tricky because first thing, the dot paper is by 2s. So when they say the locus of all possible locations, they're basically just saying the circle. So if Baker is represented by D and is 10 miles to the center, it could be, we're going to count 5 spaces, and this is halfway between. So 1, 2, 3, 4, 5. It could be there, because that's 10 miles. It could be 1, 2, 3, 4, 5. It could be here, 1, 2, 3, 4, 5. Or it could be 1, 2, 3, 4, 5. So basically what you would want to do now is take your protractor, your compass, I mean, put it here, bring it over here, it cooperates, and draw the circle around. That's what we mean when we say graph the locus of all possible locations. So if this is 10 miles from the center of the earthquake could have been in any of those places. But Colt was only 5 miles. So 1, 2. So it looks like Colt would be about here. That's 5 miles. Once again, we're going to take the protractor. I think we're going to take the protractor. Put it there. Put the tip of the pencil there. And draw it around. You can start to see that if its center of the earthquake was 10 miles from Baker and 5 miles from Colt, it looks like it was right here. Now they also say that it was 13 miles from Abbott. So 1, 2, 3, 4, 5, 6. Looks like it would be about here. So if I take this and move it around, actually, and so actually something has gone off here. Let me see what I did wrong there. Let me undo that circle. Let me try using my pen. So 13 miles, so that's going to be 6.5 spaces. That's half. 1, 2, 3, 4, 5. There we go. It's over there. Okay. I want to get that all lined up. And now draw it around. And so I can see that the center of the circle, center of the earthquake, would have been down there somewhere. And that space is 13 miles from Abbott, 10 from Baker, 5 from Colt. Am I going to make you do this problem on your test? No, but you definitely could see something like it on the EOC. I hope this all review has helped you. Enjoy!